Good morning, everyone. Let us start this session. So, in this session, we will study the pressure measurement devices. So, in the previous session, we have seen the hydrostatic law. So, in the pressure measurement devices, we have a manometer. So, this is the U-tube manometer. Then, second is the piezometer. And then we have the differential manometer. Okay. So, all these three devices, that is a manometer, piezometer, and the differential manometer, they are based on the hydrostatic law. Okay, so you know the hydrostatic principle, the pressure at any point in the static fluid, this is equal to rho g h. Okay, so on this single equation, we will design the manometer, piezometer, and the differential manometer. So before that, we will see the types of pressure we measure. So we have, first is the gauge pressure. Then we have the vacuum pressure. And third is the absolute pressure. Okay, so these three types of pressure we generally measure. So what is meaning of gauge pressure, vacuum pressure, and the absolute pressure? So there is one reference line, and this reference line for the pressure, this is called as a absolute zero. Okay. So with respect to this absolute zero, we measure the pressure. So here somewhere we have the line. This is called as a atmospheric pressure. And the atmospheric pressure, this line, this is 1.013 bar. So this is our atmospheric pressure. Okay. So if you measure the pressure above this line, let us take somewhere here. Suppose we have this point as a point A. Okay. And we measure some pressure measurement device like one pressure gauge. Then the pressure at this point, this is taken as a gauge pressure. So gauge pressure, this is nothing but, so I will write here gauge pressure. So the pressure measured by considering the atmospheric pressure measured by considering the atmospheric pressure as a reference or the datum, Okay, so that pressure is called as a gauge pressure. So what is meaning of this reference or the datum pressure is we neglect the atmospheric pressure. So actually atmospheric pressure is 1.013 bar. Okay. So for the gauge pressure, we just measure this pressure. Okay. So we consider this atmospheric pressure to be zero. So we consider atmospheric pressure to be zero. So actually it is not zero. There is a pressure of 1.013 bar, which is called as the atmospheric pressure. Okay. So pressure measured by taking the atmospheric pressure line as a reference line or the datum line. This is called as a gauge pressure. Okay. What is vacuum pressure? So vacuum pressure is, suppose I select one point which is below the atmospheric pressure line. Okay. So at the point B, if you measure the pressure, let's take this PB, then this pressure, this is called as a vacuum pressure. Okay. So vacuum pressure is defined as the pressure below the atmospheric pressure. So second type is a vacuum pressure. So it is the pressure below the atmosphere or atmospheric pressure. So this is called as a vacuum pressure. Okay. So this pressure, so vacuum pressure is a negative. So for example, -5 bar. So if you represent the pressure as a negative, it means that it is the vacuum pressure. Okay. So here you can observe the vacuum pressure. So vacuum pressure we can see in the vacuum suction devices, okay, or the vacuum cleaners. So whenever there is a negative pressure, so just imagine this is the tube for the vacuum cleaner. So this is the vacuum cleaner, okay, and here we have some plastic or the paper particles. So when we create the vacuum, it will suck this object inside this tube. Okay, so that means here the pressure is below the atmosphere. So here pressure is atmospheric. Okay, and inside this tube pressure is below the atmospheric pressure. Okay, and therefore it will suck the particle inside this tube. So this is the application for the vacuum pressure, and this pressure is represented as a negative pressure. And third, we have the gauge pressure. So gauge pressure means if you measure any pressure with respect to the absolute zero, then we call this as a gauge pressure. Okay. Sorry, it is not a gauge pressure. This is the absolute pressure. So absolute pressure means if you measure any pressure with respect to the absolute zero, then we call this as absolute pressure. So this is the absolute zero pressure line. So this is absolute zero pressure. Then this is the atmospheric pressure. So this is the P atmosphere. Okay. And suppose we have one point which is the above atmosphere. So at this point, pressure is above the atmospheric pressure. So this point, let us take A, and we want to measure the pressure at this point. Okay. So this total is nothing but the absolute pressure. So at point A, if you want to measure the absolute pressure, then we can write the equation. Pressure at point A, which is the absolute, this is equal to P atmosphere plus P gauge pressure or gauge pressure at point A. Okay, so this is the formula to find out the absolute pressure at any point. So we have to consider the atmospheric pressure. Okay, so actually here P atmosphere, let us take, we know the atmospheric pressure, this is equal to 1.013 bar. Okay, and if you measure only this difference, so it will become the gauge pressure with respect to atmospheric pressure. Okay, so at this point gauge pressure PA gauge pressure, this is equal to let us take this 2 bar. Okay, so total pressure which is the absolute pressure. This is equal to 1.013 bar plus gauge pressure is 2 bar. Okay. So meaning of gauge pressure is the pressure measured above the atmosphere. By neglecting, there is atmospheric pressure. Okay. So total pressure or the absolute pressure is equal to 3.013 bar. This is the absolute pressure at the given point. Okay. So you must have seen some pressure measurement devices. Suppose we have the compressor. So all of you have seen the compressor at the tire repairing shop. Okay. So for this compressor, there is one pressure gauge, and it shows some reading, something 22.5. Okay. So this is in PSI. So generally we have the pressure limit for the two-wheeler tires as something 22.5, 25 PSI. Okay. So this pressure we can measure with the help of this pressure measurement device. This is called as a Verdon tube pressure gauge. Okay. So this pressure gauge, they directly give the gauge pressure. Okay. That means this pressure. So this devices has been designed so that they will consider the atmospheric pressure as a zero. So for that, we assume this atmospheric pressure as a zero line or the datum line. This is the datum line or the reference line. And with respect to this line, we just measure the pressure. So this is called as a gauge pressure. But if you measure the pressure with respect to absolute zero, this total pressure, this is called as a absolute pressure. Okay. And the formula is atmospheric pressure plus gauge pressure. Okay, so these are the three types of pressure that we generally measure: gauge pressure, vacuum pressure, and the absolute pressure. Okay, now let us see the pressure measurement devices. So piezometer, manometer, and the differential manometer. So first device is the piezometer. Okay, so piezometer, it is just a vertical tube, and it is connected with the container, okay, or the pipeline in which we have to measure the pressure of the liquid. So here you can see, so this is the water tank, okay, and for the water tank, at the bottommost point, we want to measure what is the water pressure. Okay, so we will just connect the vertical tube at this point. Okay, and when we connect the tube, and if you open this, then water will flow inside this tube like this. Okay, and after some time, at a particular level, there is an equilibrium. So this height in this piezometer tube, so this is your piezometer tube. So from this height h, we can directly find out what is the pressure at this point. Okay, so this pressure we can write by this equation, which is the hydrostatic law. P is equal to, suppose this point is A, so it is a PA, and this is rho G H. Okay, so this H is nothing but the height above this point for this liquid. Okay, that is a liquid in the piezometer tube. So this will be density of the water. So right now the liquid in this tube is water. Then G is the gravity into HA, that is height above the point A. So by using this formula, we can find out the pressure at this point A, and this is in Newton per meter square or the Pascal. Now this pressure, it is the gauge pressure. This is the gauge pressure. Okay, that means we are neglecting the atmospheric pressure. Okay, so actually above this layer, we have the atmospheric pressure. Okay, so this is our atmospheric pressure. But to find out the gauge pressure, we assume atmospheric pressure to be 0. Okay, and just we calculate the pressure due to the liquid height. Okay, so this is the liquid height in this piezometer tube, and because of this height, we get this pressure, which is the P. Okay, and other use of the piezometer is piezometer will directly give the height of the liquid in this tank. Okay, so just imagine this is the closed tank. Okay, and we don't know what is the liquid height in this tank. So if you connect the piezometer, then just by observing the height of the liquid in this piezometer tube, we can give the height of the liquid in this tank. Okay, so it is the same height. So piezometers, they are used to measure the pressure in the pipeline also. So suppose we have the pipeline like this. Okay, and some liquid is flowing in this pipeline, and at a particular point we want to find out the what is the pressure. Okay, so just you can connect the piezometer tube. So just connect one vertical tube, that is a vertical glass tube, which is a transparent, like this. Okay, so at this point, so when the pressure when the fluid is pressurized, then up to certain level the pressure will rise in this tube. Okay, so let us take liquid or fluid. So it will rise up to this height. This height is h. Okay, so at this point, let us take point A. So we can give the pressure PA. This is equal to rho G into H. Okay, so just by connecting one single glass tube, we can find out the pressure in the pipeline. Okay, at a particular point, and it is given by this hydrostatic equation. P is equal to rho G H. So here just we have to take the density of the liquid in the pipe, G is the gravity, and H is the height in the piezometer tube for that liquid. So here you can see if the liquid level in the tank, if it rises, then you will get the same rise in the piezometer tube. Okay, so you can observe the rise in the liquid in the tank and in the piezometer tube. So piezometers, they are used to measure the pressure at a particular point, and also they can give the height of the liquid in the tank. Okay, so this is about the piezometer. Second device is the U-tube manometer. So what is YouTube manometer? So YouTube manometer, it is the glass tube which is bent in a U shape and one end of which is connected to the point at which pressure is to be measured, and other end it remains open to the atmosphere. Okay. So here you can see we want to measure the pressure at this point. Okay. In this tank. So let us take this point is A. So we want to measure the pressure at this point. So we have connected this YouTube manometer or U-shaped glass tube. So this is the simple construction of the YouTube manometer. Okay, so it is just an glass tube. And in this glass tube, there is one manometric fluid. So this is the manometric fluid. So generally, this glass tube, it is filled with the mercury as a manometric fluid. So this is manometric fluid. Okay. So manometric fluid, it is having the density greater than the density of the liquid in the tank, okay, or for which we want to measure the pressure. So this density of the manometric fluid is greater than the density of the fluid for which we want to measure the pressure. Okay. So let us take, we want to measure the pressure of the water in the tank. Okay. So we will use the manometric fluid as a mercury. So most of the time we use mercury as a manometric fluid. So it is having the highest density. So this density for the mercury, this is equal to 13,600 kg per meter cube. Okay. So this is just on construction. So here we have the YouTube U-shaped glass tube. Then we have the mercury as a manometric fluid. Okay. Now we will connect this to a fluid for which we want to measure the pressure. So just we will connect this by using one pipe. Okay. And suppose here we have the tank which is filled with the water. Okay. So water will apply the pressure on this fluid, and because of that, this mercury, so it will shift in the right limb. Okay. So this is the right limb and this is the left limb. So you can see. So when we open this wall, so water will flow in the YouTube manometer. Okay. And it will apply the pressure. And therefore you can see the rise of the mercury level. So mercury level will rise in the right part or right limb, and it will achieve some equilibrium, okay, after specific displacement. So at this equilibrium, we will consider the reference line. So here we will consider this reference line. Okay. So this reference line is a XX. And now use the hydrostatic principle for left part and the right part. Okay. So at the reference line XX, pressure in the left limb it is equal to the pressure in the right limb. Okay, so I will consider this point to be A and this point is B. Okay, and here we want to measure the pressure at this opening, so that pressure is P only. Okay, so this height, this is given as H1, which is above the point A or above the reference line in the left limb. The height in the right limb only for mercury, and this is equal to H2. Okay, so in the left side we can write the equation as this pressure is P plus pressure due to this liquid height, which is a H1. So pressure due to the liquid height So this is P plus pressure due to the liquid height H1 of the water, because in the left side we have the water above the line XX. For the right limb, just we have the pressure due to the liquid height H2, and this liquid height is nothing but mercury as a manometric fluid. Okay, so just consider this manometric fluid as a mercury. So this is the pressure equilibrium equation at the reference line XX. Okay, so that means pressure at this point A, it is equal to pressure at the point B, because in a static fluid, so this is the free surface of the liquid or the fluid. So along the horizontal direction, pressure remains same. Suppose we have point A and point B. So pressure at point A, it is equal to pressure at point B. So same principle we can use here. In the horizontal direction, pressure will remain same. So pressure at point A, it is equal to pressure at point B. And then you can write the total pressure. So this is the total pressure at point A, and this is the total pressure at point B. Okay, so this is equal to P plus pressure due to the liquid height H1. So this equation is rho G H1. So right now rho is nothing but rho water. Okay, because in the left side we have this water. This is equal to pressure due to the liquid height H2 of the mercury. So that is equal to rho mercury into G into H2. Okay, and by using this relation you can find out the unknown pressure P, which is equal to the rho mercury G into H2 minus rho water G into H1. Okay, so in this way you can find out the pressure in the water tank. Similarly, you can use this device to find out the pressure in the pipelines. So in that case, you will connect so if you want to find out the pressure at a particular point in a pipeline by using the manometer, that is a YouTube manometer. So this is the pipeline and some liquid is flowing through this pipeline. Okay, and at a particular point, let us take this point as a. We want to measure the pressure by using the YouTube manometer. So just connect the YouTube manometer like this. Okay, So here we are using the manometric fluid as a mercury only. So this is the mercury. So you can observe some level difference in the mercury in the left and the right limb. So this is your reference line. At this point, pressure will be PA. Okay. And suppose this is the water in the pipe. So here you can see the water. So this complete part, it will be filled by the water only. Okay. And then you can select the reference line, which is the XX. Okay. Just measure this height in the left part or the left limb. Measure this height for the mercury in the right half. So this is your H2. This is the H1. And then by using this principle, pressure is same in along the XX direction. You can write this equation. PA plus rho water G into H1. This is equal to rho mercury into G into H2. Okay, so you can find out the PA. Okay, so this is the use of U-tube manometer. Okay, so why we are using the U-tube manometer if you have the piezometer device? Okay, so piezometer is much simpler in construction. Okay, compared to the U-tube manometer. The advantage of using U-tube manometer is we can reduce the height of that glass tube. Okay. So suppose we are using the glass tube. For the measurement of the pressure. Okay. So for the high pressure, we need to increase the height of the glass tube, because finally the pressure, it depends on the height as this principle rho GH. Okay. So if the pressure increases, suppose we are measuring the higher pressure, we need to have the glass tube with the maximum height. Okay. So that will put the constraint on the use of that piezometer. So what we can do, we can use the U-tube manometer. So in the U-tube manometer, when we use the heavier fluid as a manometric fluid, suppose we are using the mercury. Okay. So when we use mercury as a manometric fluid, then actually we are reducing this level difference. Okay. So we can use the small height tube as a U-tube manometer for measuring the higher pressures. Okay. Right now mercury is having 13,600 kg per meter cube. This is the density. What is the density of water? So water is having just 1000 kg per meter cube as a density. So mercury is 13.6 times heavier than water. Okay. So therefore we are decreasing the height or level difference by this much amount, 13.6 times. Suppose if you find another liquid having the higher density than mercury, okay, then it will further reduce the level difference. Okay, that means we can decrease this height of the U-tube manometer in order to measure the higher pressures. Okay, so that is the use of U-tube manometer compared with the piezometer. So I will show one video for U-tube manometer. So in this demonstration, actually we are not measuring the pressure in the pipeline. So just see how the manometric fluid, it rises in the right limb. Okay, so here you can see this red portion is the manometric fluid. Okay, This is the left part or the left limb. So on the left limb, we have connected one tube or the pipe, and we are just blowing the air. Okay, that means we are applying the pressure, and therefore this complete left part, it is filled with the compressed air. Okay, and because of that compressed air, the manometric fluid, it will rise in the right limb. Okay, and then you can see the level difference. So this is the level difference due to pressure. So for the pressure measurement, when we are performing any experiment or we are measuring the pressure, we have to just find out this level difference. Okay, and then by using the hydrostatic principle, we can find out the pressure. So right now we are measuring the pressure in that balloon. Okay. Okay, so this is how you can use the YouTube manometer.